Good morning, friends. This is our another session in the same topic, relativistic quantum mechanics. As you know, myself, Dr. PALANIAPPAN, Professor of Physics, Department of Physics, ANNAMALAI University, discussing in the topic of relativistic quantum mechanics. We are supposed to derive a valid relativistic quantum mechanical equation. This problem was taken by various scientists, and one by one they have suggested their own idea and derived their own methods. The very first was given by Schrödinger himself. We call that equation as Schrödinger's relativistic quantum mechanical equation, the very first equation in the topic, and that equation has having serious defects. That was rectified by Klein-Gard and KG. They have made new assumption, and the new assumption also seems to have defects because their equation is not applicable for spin half particle electron system. That equation gives a error values. So again, the attempt continued by Dirac, and Dirac supposed to get a valid quantum mechanical equation by adopting the Schrödinger's original procedure along with a new idea. So this is Dirac's relativistic quantum mechanical equation. Basically, Dirac has accepted Schrödinger's concept. What Schrödinger told, they fully accepted. That is one thing, classical quantum equivalence. Dirac has accepted fully. Second thing, implement this classical quantum equivalence in relativistic classical mechanical equation. These two is a main idea of Schrödinger, and Dirac has accepted these two concept of Schrödinger. Further, Schrödinger told a valid equation should be a linear type equation. Linear equation should be adopted for getting the equation is the idea given by Schrödinger. KG has contradicted in this point, and they told relativistic equations need not be linear, but Dirac also accepted the linear equation. So all the points of Schrödinger was accepted by Dirac, but what the Dirac has made is he find a new method to take the square root of the equation. The relativistic classical mechanical equation is E square equal to C square P square plus M square C power 4. While taking square root, Schrödinger do like this way. Taking square root on both sides, there is a plus or minus C square P square plus M square C power 4. This is the method by Schrödinger, and while taking square root, an appearance of negative sign is there, and this creates some problems along with another problem. But Dirac has changed the method here. He find a new approach to take a square root. See, for example, I have an equation x square equal to say 10 square plus 20 square is an equation. What the actual answer is, x square equal to 10 square is 100, 20 square is 400. So first you have to add. So x square equal to root of 500. It is around 20 to 22, like that. The answer will be there. So it is the actual method of taking square root. This answer is perfect, correct. This is the usual procedure we will adopt. If I put x square equal to 10 square plus 20 square, in the next step, if I put x is equal to 10 plus 20, then this method is a wrong method. This is usually a wrong approach. What Dirac did is that he put x square equal to 10 square plus 20 square. Then the next step, he directly take root. Of course, this is a wrong method. He put there is an error in this thing, and the error is corrected by a correction factor A plus instead of 20 square you put a 20B. Doing like this is fully error, is having a definite error. That error has to be corrected by determining the factors A and B, including that, then we will generate a correct answer. See, for example, if I found A equal to 1 by 4 and B equal to 1 by 1, then substituting this, we have A equal to 1 by 4 means it is 10 into 1 by 4 is 2.5 plus 1 by 1 is 20 is giving you 22.5, almost the same answer you can get. So, it is a different approach of taking a square root, and this method was suggested by Dirac in deriving the equation. The actual equation is E square equal to C square P square plus M square C power 4, or it is E square equal to Cp whole square plus MC square whole square. By applying Dirac's approach, Dirac has shown that E equal to, he takes direct square root, so Cp plus MC square, and there will be an error in each term. That error in first term is corrected by inclusion factor alpha, and the error in second term is corrected by a inclusion factor beta, where alpha, beta are correction factors for Hamiltonian. So, this is the approach of Dirac, and he determined that alpha and beta value are matrices. How he determined them as a matrices and what are the value of these matrices is a separate topic. It is a very lengthy process. Now, for time being, we can take the correction factors as alpha and beta. Alpha is correctly called as momentum correction factor because it is along with the P. C is velocity, P is momentum. Since alpha appears along with the P, we call alpha is momentum correction factor, whereas beta is MC square. MC square is the energy value, so beta is called as energy correction factor. So, two correction factors are introduced by Dirac. One is a momentum correction factor, another one is the energy correction factor. These two factors are determined by Dirac himself, and he applied various commutation relations and found that alpha and beta should be a 4 by 4 matrices. Further, alpha being a momentum component, it has alpha x, alpha y, alpha z, and beta is having no components because it is a scalar value, energy value. So, beta is simply as a beta, and with this inclusion, we have E equal to alpha Cp plus beta MC square, replacing E by IH cross dou by dou t, dou psi by dou t, that is Schrodinger's classical quantum equivalence for E equal to alpha C. For P, the parameters minus IH cross del alpha C into minus IH cross del plus beta MC square. So, and you have to include wave function psi in all the terms. So, the equation becomes this one, and this we call as Dirac's relativistic quantum mechanical equation. So, here we have to find alpha x value, alpha y value, alpha z value and beta value. These four are matrices, and the four matrices are called as Dirac matrices. The evaluation of Dirac matrices is a lengthy process to be taken in the next session. So, with this all the three quantum mechanical equations are over, and finally, Dirac's equation seems to be a valid relativistic quantum mechanical equation. Thank you. Thank you, friends. Thank you for your patience observation, and if there be any doubts or if you need any clarifications, kindly email me, and my email address is lp_dde_au@yahoo.com. You can freely email and I will definitely respond. Please give your feedback and suggestions to this email ID. Thank you, not all.